everyone, today we are going to study number system chapter 1. In your earlier classes you have learnt about the number line and how to represent various types of numbers on it. Just imagine you start from 0 and go on walking along this number line in the positive direction. As far as your eyes can see, there are numbers and numbers. Now suppose you start walking along the number line and collecting some of the numbers, get a bag ready to store them. You might begin with picking up natural number like 1, 2, 3 and so on. You know that this list goes on forever. So now your bag contains infinitely many natural numbers. Recall that we denote this collection by n. This is the bag full of n. Now turn and walk all the way back. Pick up 0 and put it in the bag. Now you have the collection of whole numbers, which is denoted by w. Now stretching in the front of your many negative numbers, put all the negative integers into your bag. What is your new collection? Recall that it is the collection of all integers and it is denoted by symbol z. Z comes from a word, German word Zahlen, which means to count. Are there some numbers still left on the line? Of course, there are numbers like 1 by 2, 3 by 4 or even minus 2005 or 2000 by 2006. If you put all such numbers also into the bag, it will now be the collection of rational numbers. The collection of rational numbers is denoted by Q. Rational comes from the word ratio and Q comes from the word quotient. You may recall the definition of rational numbers. A number R is called a rational number if it can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Why do we insist that Q is not equal to 0? Notice that all numbers now in the back can be written in the form of P by Q, where P and Q are integers and Q are not equal to 0. For example, minus 25 can be written as minus 25 by 1. Here P is equals to minus 25 and Q is equals to 1. Therefore, rational number also include the natural numbers, whole numbers and integers. You also know that a rational number do not have a unique representation in the form of P by Q. Here P and Q are integers and Q is not equal to 0. For example, 1 by 2 equal 2 by 4 equal 10 by 20 and it is equal to 25 by 50. Equals to 47 by 94 and so on. These are equivalent rational numbers. However, when we say that P by Q is a rational number or when we represent P by Q on a number line, we assume that Q is not equal to 0 and that P and Q have no common factors other than 1, that is P and Q are co-prime. So on the number line among the infinitely many fractions equivalent to 1 by 2, we will choose 1 by 2 to represent all of them. Now let us solve some examples about the different types of numbers which you have studied in earlier classes. Are the following statement true or false? Give reasons for your answers. Every whole number is a natural number. Every integer is a rational number. It is given true or false. Every whole number is a natural number. False. Because every natural number is a whole number, not every whole number is a natural number. Every integer is a rational number. Yeah, we can all integers can be written in the form of P by Q. This is true. Every rational number is an integer. It's false. Example 2. Find 5 rational numbers between 1 and 2. 5 rational numbers between 1 and 2. We can do it in many ways. First, 2, 3. There are many rational numbers, infinitely many natural numbers between 1 and 2. So we have to find 5 rational numbers. So we will multiply by 6. Here it will come 6 by 6 and 12 by 6. So we can write numbers between it like 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. These are 5 numbers. And the second method is r plus s by 2. It is a method in which r is the r in this question r is 1, s is 2 and by 2. 3 by 2 is also a number between it. So you can also calculate or find 5 rational numbers between 1 and 2. There are many ways, and there are infinitely many rational numbers between any two numbers. Notice that in example 2 you are asked to find 5 rational numbers between 1 and 2. But you must have realized that in fact there are infinitely many rational numbers between 1 and 2. In general, there are infinitely many rational numbers between any two given rational numbers. Let us take a look at the number line again. Have you picked all the numbers? Not yet. The fact is that there are infinitely many more numbers left on the number line. There are gaps in between the places of numbers you picked up, and not just 1 or 2 but infinitely many. The amazing thing is that there are infinitely many numbers lying between any two of these gaps too. So we are left with with the following question: what are the numbers that are left on the number line called? How do we recognize them? That is, how do we distinguish them from rational numbers? These questions will be answered in the next section.